I would like to invite Mohammad Sharjeel. He is a PhD student at Center of Excellence in Water Source Engineering, and his topic is analyzing frequency of flood in Upper Indus Basin under various climate change scenario. Sharjeel, please.
Bismillahirrahmanirrahim. Is I am audible?
Yes, and please complete within 5 to 10 minutes and skip the
Okay.
introduction and literature view part. Thank you very much.
This is Sharjeel, an agriculture engineer, and my topic is analyzing frequency of flood in Upper Indus Basin under various climate change scenarios. Background and introduction. As we know, glaciers in Pakistan comprises 13,680 square kilometer, out of which Upper Indus Basin has 13% rocky area. And recently, Indus Basin have faced a lot of destructive flood even due to climate change. To overcome this effect of this flood, management of land is very important, which could be done by estimation flood frequency analysis. And we use Gumbel distribution method to find the flood frequency analysis. Problem statement. Our problem are Indus Basin have been facing a lot of destructive flood event. The behavior of basin is increasingly becoming unpredictable due to climate change and rainfall and temperature resulting in developing extreme flood events. Research objective. The objectives are analyzing frequency of extreme event occurring in Upper Indus Basin, analyzing impact of extreme event on volume of flow of the river, suggesting policy to encounter the changing behavior of the Upper Indus Basin, which will be discussed in the last part. My study area is Upper Indus Basin, which lies 31 to 37 degree north and 72 to 82 degree east, with temperature range of 18 degree to minus 2.3 degree temperature. Data collection. Data of Bishamgila station of flow is collected from WAPDA over 47 years from 1969 to 2014. Method. Gumbel distribution method is used for flood frequency analysis because Gumbel distribution deal with extreme events. As we know, our floods are extreme event. That's why I use this Gumbel distribution method for estimation flood frequency analysis. Here are some equations. Xt is equal to x plus k sigma x, where xt represent the flood at return period t, k represent frequency factor, and sigma represent standard deviations. Methodology. From 1969 through 2014, annual peak flood data was compiled. From the maximum flood data of n years, the mean and standard deviations are determined, and then value of yn and sn are 0.547 and 1.157 for n is equal to 46 based on Gumbel extreme value distribution table. As we number of years are 47, so the value of yn and sigma n is drawn from this table of Gumbel distribution, which shows yn value 0.5473 and sigma n value 1.1557. Result and discussion. The Gumbel distribution research was conducting using the technique of stated above, and the findings are shown in table. Here is table. Here is years from 1969 to 2014. This is the peak flood discharge according to the years. Then we arrange the flow in the descending order. Here is the order number. Here we find s square is equal to n minus x. N represent the order total number of years of your study. X represent the peak flood values. Then we find the return period by using this formula. TR is equal to n plus 1 over m. And then at the end we calculate the reduced variate of this data. According to the statics, the maximum flood flow in 2010 was 18,220 cubic meter per second at Beshamkila, while the lowest flood flow was 7,355 cubic meter per second in 2004. The 47-year mean instantaneous flood flow is 10711 cubic meter per second. Gumbel method was also used to estimate flood with various recurrence interval. Here are return periods in the future with 2 years return period, 10 year, 50 year, and so on to 400. And then we find the expected flood by using the Gumbel distributions equation. We show that after 2 years there will be flow of 10,418 cubic meter per second, and for 400 years after there will be flow of at Beshamkila 19,561 cubic meter per second. The findings show that the predicted flood in the river reach from return period of 2 years, 5 years. The approach mentioned above can be used to estimate or explorate other values not included in the chart. We also draw a graph between peak flood and reduced variate and find the coefficient of determination, which show value 0.94. Describe the consistency of data. Conclusion, 47 years data was collected in upper Indus Basin. We calculate the coefficient of determination, which show values of 0.9649. The mean instantaneous flow in the river is 10,711 cubic meter per second, which having a return period of 2 years. Recommendation, there will be more station for the flow data measurement, which would be helpful for prediction of flood in various parts of upper Indus Basin. Also, there should be large data of flow of past year to accurately estimate of extreme events. There should be more dams in upper Indus Basin so that large quantity of flow is stored in dams, and the impact of flood could be reduced by storing the excess water or overflow water. Government should also allocate a significant amount of budget for constructions of dams. Thank you. Is anyone have any questions?
Thank you.